put the box in and then fill it in with concrete. And he did 2 of them, and he realized that he was not cut out for concrete work, so he no longer installs quick tread edge pitches. Okay. The one thing I haven't actually explicitly explained, thank you, ecal. So we have balancers, obviously, without ecal. Okay. A regular balancer without ecal looks at the tire and does the shimmy and the shake, and the shimmy and the shake. The shimmy and the shake, we actually, our force transducers work together to tell us what number we need either on the inside or the outside. A traditional balancer, the left one's going to do the inside and the right one's going to do the outside. Ours, since we look at the whole tire together, they can actually work together to figure out, am I counterbalancing whatever's going on. Okay. Ecal doesn't necessarily, ecal minutely affects the calibration of the balancer in, like, again, the tenths or the hundredths of an ounce. Okay, it's not like it's going to change whole ounces. So if you have an older balancer, it's not like we made junk balancers until like 5 years ago when we came out with ecal. So when I trained, I would tell people, you bought it, thank you for buying the balancer. Every Monday morning, you're still a little groggy. You hadn't had your first cup of coffee yet. You hadn't had your cigarette yet. You're still just trying to you made it to work, but are you really at work? You're not really at work. So while you're trying to like ramp yourself up for another exciting week of work at wherever you're working at, calibrate the balancer. Okay, there's a 3-spin calibration. It takes about a minute, minute and a half, depending on how many sips of coffee you make. Okay. So you would calibrate the balancer every Monday morning, then you do the whole week, and then Monday morning when it come around, you calibrate the balancer again. I'm not sure if it was people up front or engineers. They wanted to be able to prolong the interval on when you needed to recalibrate the balancer. Evidently, they didn't like it that we're teaching people that they had to calibrate the balancer once a week. And they were like, well, if we could prolong how often we need to calibrate the balancer, it works into the ROI that you're not having to recalibrate it, even though it only takes a minute. You don't have to worry about, oh, I didn't recalibrate it this week. All my tires are going to come back or something like that. So they came out with something called ecal. And the E in ecal, just like E in EV, stands for electric. That's why we have the piezo's and we send the signal through and we do all that, right? So the one thing that for years and years and years and years and years and years and years we hadn't taken into consideration, or we didn't know how to take into consideration, was the balancer tub when it gets hot and cold, right? When metal gets cold, it shrinks. When metal gets hot, it expands. Now, for those of you who have ever seen a balancer in a 110-degree shop, it's not like it looks like the Michelin Man, right? After he had too many brownies, right? You can't see the tub expanding. Conversely, if you're in Ohio in the middle of a snowstorm, the thing doesn't lose square feet because it's like, crumpling like that Titan submarine, right? I'm not in it. No, not too soon for me.
They are yours.
No, they are not.
Shake your mouse.
Oh, motherless man.
They make a program that will shake your mouse.
Yeah, I just need to go into power settings. I just need to go into power settings and move it. Ah.
No, I heard it. I can't filter out sound. That's $1 million job.
Not what I wanted. Rather than once a week, they wanted to be able to say that our balancers are so advanced and so amazing and so awesome that you didn't have to calibrate our balancers but once a month. So they turned their eyes to the one thing that could affect the calibration, right? Because if you calibrate it in the morning and it was 18 degrees in the morning and then it's 55 degrees in the afternoon, the balancer tub is going to expand incrementally, right? Not you won't be able to measure it, right? It's probably thousandths of an inch, but the balancer expands so that there's less force on the force transducer, so it affects it just a little bit. Likewise, if you calibrate it when it's 55 out and it drops down to 18, the balancer tub shrinks, so there's a little more pressure on the force transducer. So now we take into consideration, because of the piezos, we can figure out if the tub is contracting or expanding, and then we can slightly modify the how much weight we put on the screen. Okay. Again, it doesn't make our old balancers less accurate. It just, we can go further beyond, three spin counts. Did you do it did you do it once a week? How often did you do it? Only when it messed up?
So ours would prompt early in the morning. So if I got that
Okay.
it was great. But otherwise, somebody else had obviously.
Yeah, we're already done. Yeah. Okay. So the legend over here. See, and this is what I hate about engineering, right? We have a red color and we have right. So a commonsensical person would have put the red transducer on the red line. No, the blue line is right and the red line is left, because who needs to have common sense? Because it would have been easy to remember if the red line was on the right, right? You just, talking to you, right? Engineer over here in the corner. So DAQ temperature is just DAQ temperature. It's the temperature of the board, okay? So if you notice my left gain, even though left is red, and I'm not mad at it at all. Okay, my left gain here, if you notice, the red line is going exactly straight across. My red line never deviates. Okay. My right gain is all over the place. My right gain looks like some type of unicorn, schizophrenic raccoon on crack, right? It's just everywhere. So, Mike, thank you. Mike Jurassic calls me, sends me this picture. He's like, this is the second week out in the wild. So, this is like around August or something at this time. He sends me this picture and he goes, what do you think? I said, well, obviously, your left force transducer is bad. Or no, your right force transducer is bad, because your left one never moved at all and your right one's all over the place. So he, studious, brand new, both of us brand new teacher, brand new student. He orders in a right force transducer and he puts it in and he waits a week and he goes back and it looks just like that. So at that point, that's when I learned that the most probable cause of any balancer problem is the DAQ board. That is a bad DAQ board. All right. And believe it or not, it's not so much the blue line that's bad, it's the red line that's bad, because the red line never moves. The red line flatlines, right? It's totally bad. Now, the blue line is also egregious, but I think the blue line is egregious because the red line's not doing anything and power's bleeding over somewhere. So, my brother has the world's worst luck with DAQ boards. He once had to put 4 in a balancer before he found a good one. Okay. Now, having said that, I'm going to tell you that 2 out of the 3 or 3 out of those 4 DAQ boards weren't actually bad. Okay. So, because I don't think he was taking this into consideration, right? He's 385, 6'9", right? So what's he doing when he's taking that DAQ board on and off the balancer? He's leaning on it, right? When you're 385 and 6'9", you're twisting the frame of that balancer a little bit, just a little bit, not a lot, right? What happens to the piezos? They're getting energized, right? What happens to an energized piezo when it's not plugged in anything? It keeps the energy, right? What happens when you finally plug it into a board but there's no electronics on it? It discharges. So I think he was discharging his force transducers every time he plugged it into the board, because when the board is on, it can deal with those voltage spikes. But when the board is off, it can't deal with those voltage spikes. So we we have what is called a shorting bar, and it's basically the plug end of the DAQ board. And all they did was is they took all the pins and they soldered all the pins together, so that when you took it and you plugged it into the lead on the force transducer, it took everything to ground, right? Because it's trying to discharge. So all you're doing is you're giving it a method to discharge. That jumper can also be used on revolution uh, proximity sensors. The not the proximity, but the piezos, right? You have the two piezos, so you can also use this jumper. If you're coming back right away, nope. Okay, fine. You can also use this. You can also use the shorting bar on revolution piezos, right? Because you can't just plug in a revolution piezo to the DAQ board because you'll break the revolution DAQ board. Hmm? Okay. So if you try to buy the shorting bar from Hunter Engineering because someone has to hand solder it together, it's like $35. However, if you order in a transducer, guess what comes on the end of the transducer? A shorting bar. Guess what you don't send back with the old one? The shorting bar. So you get a free $35 shorting bar thing. If I can't find it here, I will go to my office. I have one in my office so that I can show you guys what it looks like, just so you can see what it looks like. Okay. So there's a gentleman over in Balancer Garage that his job is to look at every single DAQ board that comes back from a balancer where they say that the balance that has a bad channel, right? Because we have a left channel and a right channel. It's almost like stereo, right? We have two force transducers. We have a left and right, so we have two channels. And evidently, the guy in the balancer garage says that like 99% of the DAQ boards that we send back are good. So they're trying to figure out why we're replacing tons of DAQ boards and it fixes our problem. But when they get back to him, he tests them and they're good. So they're working on that. So that's a bad DAQ board. So don't bother wasting your time buying two force transducers and putting two force transducers in it. Um, put a DAQ board in it. Now here, and again, another reason why he left the engineering field. We make a board. You guys are not allowed to replace a component on the board. They're called surface mounted components. Okay. This is how engineers go to sleep at night. If we do have a bad DAQ board, it's one of the surface mounted components that we buy from another company. So guess what the engineer tells himself? My board is fine. It's a surface mounted component problem. Do we care it's a surface mounted component problem? No, it's a bad DAQ board. But so they don't you know, go off and do awful things to themselves at night because they can't make green boards. They have to rationalize themselves that the part of the board that we make is fine, but we're buying this transistor from Malaysia for like 3.5 cents, and that transistor's family. Yes. You can't swap the channels because again, the right force transducer oscillates twice as high because it's twice as close to so you can't use the balancer to balance a tire because this one is twice as high as this one, and then if you change it, it it doesn't know you changed it, so it's going to tell you to put the weight on this side rather than on this side, but then it's going to ask. It doesn't work that way. Put a D, put put a DAQ board on it. I do actually. Hopefully, let me see if I can find it. Yeah, you put it in the Mac hole. Don't put it in the Mac hole. Put it in the Windows hole. Don't put it in the Mac hole. You know what we're gonna do? I'm gonna show you a good one when we get these balancers back together again, because I'll have a good one when we get the balancers back together. Because believe it or not, I probably don't have a good. So I probably don't have a good one, but one of these balancers I can hook up to the HDMI input, and we can actually put that balancer up on the screen, and then we can watch it. Basically, what you're looking for is it's like Zen. or yin and yang. You want a nice flowing, no, backwards. You want a nice flowing river. You want them to move together. Okay. So if one goes up, they should both go up. If one goes down, almost like a symphony. How's that? More like a symphony. Okay. So you don't want them to diverge. Remember the movie TV series Divergent? You don't want them to diverge from each other. You want them to move like in concerto. Yes. Right. Yeah.
Is there a specific amount of space between the lines where you can start to know it's going bad? Or?
No. So that's another thing. We've had ecal force transducers now for over 10 years, and my brother's probably put in 2 transducers in 10 years. Okay. They just don't go bad. It's always a DAQ board. So, surface mounted component on the DAQ board. All right. Right. Yeah. It's not Hunter Engineering's fault. It's whoever So then we go back to the transistor people and we're like,
So we can tell our customers that where they're like, oh, look at this crap.
Surface mounted component. Yeah. Oh. Yeah. Okay. So that's so that is that's ecal. Okay. Yeah, ecal does affect the overall calibration very, 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 very slightly, but it's not like by ounces. It's not even by, it might be like by tenths of an ounce, right? So you might round up or down depending on it. So I don't want you guys to think that, a balancer 20 years ago was junk. Okay. Lastly, before you guys go back together with all this stuff, you're fine. Force transducers. Hopefully all of your force transducers had some washers, right? You should, the nut should have pushed on a washer, and then the washer should have pushed on some red steel. Then there was another washer and another nut. You're going to stand up in just a minute. Stay with me. Fight the urge. I know the steak is heavy. All right. Force transducers. You have to put these in, and this is another thing. That's why you always want to have the shorting bar on here when you either replace or adjust. Now, a lot of times people will go in and they'll check the adjustment on the force transducers. And while they do that, the balancer's off. This is plugged into the DAQ board. Guess what they did to the DAQ board when they messed with this? They just broke the DAQ board. So then they adjust the force transducer, turn it on. The DAQ board is now bad. While they're standing there, they put in a neutral, and they're like, oh, look, the DAQ board fixed it again. But it's because they adjusted this without unplugging this from the board and putting the shorting bar on here. So, shorting bars, very important. All right. I'm gonna show you what it looks like. Yeah, before you plug these in. So before you plug all of these in, use the shorting bars that I'm going to provide to you, okay? All right. You're going to install this in the balancer. When you install this in the balancer, it's very important to look at the vibration structure, because sometimes when we're welding up the vibration structure, we can get a little bit of slag, and there's that little bit of pinpoint. So you want to make sure there's no slag on where you're going to mount this to the vibration structure, okay? You're going to put the force transducer in. You're going to put your green bar on. You're going to take these two 3/16 Allen bolts, and you're going to tighten them to 60 inch-pounds. Or if you, 70 inch-pounds, because 72 inch-pounds is 6 feet. So 70 inch-pounds or 6 feet. Okay. I'm sorry? No, those are foot pounds. Foot pounds, inch pounds, right? Inch pounds. We don't have inch pound torque wrenches here. Figure out what 70 inch pounds feels like to you. Basically, it's like it's snug, and then you just go, ugh, and then you're at 70 inch pounds. Okay, that's about 6 foot pounds. Yeah, it's about 6 foot pounds. Okay, so then. So, because all we're doing is we're making sure that we're getting a good solid, click, 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 click. All we're doing is we're making sure that we get a good solid contact between this and the actual vibration structure, okay? Then what we're doing is we're putting some tension on the rod. You know how like you have pre-tension and post-tension concrete? We're pre-tensioning the rod so that the rod is pushing on the piezo. So you're going to take the inside nut. You're going to run the inside nut up to either the, if this is the right side, you're going to run the inside nut to the back of the frame. If this is the left force transducer, it sits like this, and the vibration structure sits like this. So take the first nut, inside nut, wait just with your fingers until it stops against the red steel. After it stops against the red steel, you want to turn the inside nut 1/2 a turn additionally. The instructions, I think the service instructions still say 1/4, right? 1/4 of a turn, we realize, doesn't give us enough pre-tension, and the piezos we don't like the way they respond with only 1/4 of a turn. So we have doubled the 1/4 of a turn to 1/2 a turn, and that 1/2 a turn gives us enough tension on this that we like the way our piezos work. Okay? After you get this to 1/2 a turn, you take the outer nut, and you're supposed to tighten the outer nut down to 25 foot-pounds. Again, we don't have a torque wrench here. 25 foot-pounds is like, I don't know, whatever you're putting a steering wheel on, right? You put the steering wheel on, give it a little, a little tug. That's about 25 foot-pounds. Okay. Yes, but if you can get a torque wrench on the outside of the right one, but if you look where the left side one is over here, you have this much space to get a torque wrench in there. And most service technicians these are 9/16, not 14 millimeter, because it's made in the USA. You're just going to put a 9/16 wrench on it, and you're just going to give it like, that felt like 25 foot-pounds. Okay. I know. All my wrenches are torque wrenches. So I know, right? This is love. So that's how you properly adjust force transducers. Okay. Like I said, a lot of people, and like what my brother will do, he'll get a call for chasing weights. He'll loosen up the outside one. He'll loosen up the inside one. He'll basically, he'll crack these free. He'll tighten them back up to what he feels is about 70 inch-pounds. Give it a 1/2 a turn, 25 foot-pounds ish, esque in the neighborhood. And, hopefully he puts the jumper on here and he doesn't waste another DAQ board. And then, he'll do some other stuff. Yeah. Yeah. Yeah.
So just 180 turn on the nut.
I'm sorry?
Just 180 on the nut.
1/2 a turn, yeah.
I want to make sure we're using the same
180.
language.
I guess if you line up the flat, you can go from 12 to 6. Yeah, 180. Okay. So I'm going to go find a shorting bar at my desk. You guys start putting these back together again.